You finish building your Spring Boot app on your own laptop. It runs great. It takes just 55 milliseconds to respond. But then you push it to production for real users. Suddenly, those 55 milliseconds become 3 long seconds. Then users complain that your application randomly freezes. You restart the server, and for a few minutes it feels better, then the problem comes back again. And this is the frustrating part. When you check the logs, nothing obvious appears. CPU may still look normal, memory may still look fine. There is no single error telling you what is wrong. That is where most developers start guessing, maybe increasing the RAM, maybe scale the pods, maybe the database is slow, or maybe Tomcat needs more threads. This is one of the worst feelings for a backend developer, and it usually happens because Spring Boot apps have three main reasons for being slow. The problem is these three issues are completely hidden during normal testing. You only see them when a lot of traffic hits your app. In this video, I will show you exactly what these three problems are, how to find them in your own code, and how to fix them easily. Let's look at the first hidden problem. Root cause number one is the n+1 query problem. Developers call this the silent killer of Spring Boot apps. It looks completely innocent in your Java code, but behind the scenes, it is absolutely crushing your database. Let's see exactly how this happens in your code. There are two ways you might accidentally write this code. The first way is by writing manual loops like this code. First, you make one single query to fetch a list of users from the database. Then you loop through every user to fetch their specific orders. But there is a second, even more dangerous way this happens. It happens automatically using hibernate annotations. Look at this entity class. It looks completely clean and standard. But if you use lazy fetching or even eager fetching incorrectly, Spring Data JPA might still trigger separate database calls under the hood. When your JSON serializer tries to read the orders list, think about the math here. If you have 200 users, your app will make 201 database queries. If you have 1000 users, your app will make 1001 database queries. This means your response time grows longer and longer as your data grows. The more successful your product becomes, the slower your app gets. And the worst part, this issue is completely hidden when you test it with just 2 or 3 users on your local machine. So how do you catch this problem happening in real time? Just open your application.properties file and turn on SQL logs by adding these two properties. Now run your application and hit your API endpoint. Look closely at your console logs. Look at this pattern. First you see one select statement for the users table. Then you see a massive flood of repeating select statements for the orders table, one row after another. If you see this exact repeating pattern in your logs, you found an n+1 bug. Fixing this completely can take an entire video, so I have created a separate video on this one. But here is the short version. So instead of a basic find all method, you can use a custom query in your repository with a join fetch keyword, or you can simply add an entity graph annotation right above your repository method. Just one single line of code change can make your API 10 times faster. Root cause number 2 is thread pool exhaustion. This means your app completely runs out of threads to handle new users. Let's look at how Spring Boot handles traffic. By default, Spring Boot uses an embedded server called Tomcat. Tomcat has a pool of threads ready to work, and the default size is exactly 200 threads. Every time a user visits your website, calls your API, Tomcat gives that user one thread. That thread stays busy for the entire duration of the request. Now imagine your API needs to call an external payment gateway, and that gateway is having slow day. It takes 3 long seconds to respond. What happens to your thread? It is blocked. For 3 full seconds, it sits there doing nothing, just waiting. It cannot handle any other user. Now multiply that by 200 concurrent users. All 200 threads are now completely frozen, waiting for the same slow payment gateway. Suddenly, user number 201 arrives. There are no threads left, so that user just sits there and waits From the user's perspective, your app is completely broken and frozen. Let's look at this simple diagram to see how it happens. So when this happens in production, developers usually panic and try a quick fix. They open application properties and increase the maximum Tomcat threads to 400 or 500 threads. This buys you a little bit of time, but it does not solve the problem. More platform thread means your server consumes way more memory. You are just delaying the crash, not fixing the root issue. So what is the real fix? You have two great options depending on your Java version. If you are using an older version of Java, you need to make your network calls asynchronous. You can switch from REST template to web client or wrap your external calls in a completable future, so you don't freeze the main request threads. But if you are on modern Java 21 or later, the ultimate fix is to simply turn on virtual threads. The third root cause is the sneakiest one of all: JVM heap pressure and garbage collection pauses. With this problem, your app runs fast most of the time, but every few minutes it suddenly freezes just for a brief moment, maybe for 200 milliseconds, half a second, or even a full second. Your users see this as random, annoying spikes in response time. But when you check your server logs, your CPU usage and memory metrics looks completely normal. So what is happening under the hood? Your Java virtual machine is running an internal cleanup process called garbage collection. And here is the part that surprises most developers. Stop the world. During a major garbage collection cycle, every single thread in your application is forcefully paused. Every active user request is completely frozen mid-execution. Let's look at this timeline diagram to see exactly how this cycle loops. There are three common reasons why this happens in a Spring Boot app. First, you might be creating too many short-lived objects inside a fast loop. Every time you use the new keyword, it takes up space on the heap. Do this too fast and the JVM has to stop and clean up. Second one, you are loading too much data from your database at the same time. If you run a find all query on a table with 500,000 rows, you just forced 500,000 objects into your server's memory all at once. And the third one, your API responses are just too massive. Building a huge 5 megabyte JSON response 100 times per second will fill up your available memory space instantly. So how do you catch this sneaky issue? You can do it easily with two simple steps. When you run the first command in your terminal to find your Spring Boot app's unique process ID number, next you can use a free tool called Async Profiler to watch your app for 30 seconds. So you can download it from the GitHub. It generates a clean HTML file you can open right in your browser. If you see wide flat bars at the top of the chart, that means garbage collection is actively stealing your CPU power. If you see orange or red spikes, those are your memory hotspots that you need to fix it first. Alternatively, if you don't want to use an external tool, you can just add a simple configuration flag to your startup script to print out dedicated GC logs. Once you add this flag, you can easily look through your new gc.log file. If you find any line that says pause full, lasting longer than 200 milliseconds, you have a memory problem that is worth investigating. Now that we know all three root causes, let's look at the ultimate checklist to keep your Spring Boot app running fast in production. So your production app is slow, but which of the three hidden problems is causing it? You don't have to guess. Here is a simple 3-step diagnosis guide that you can easily run in under 10 minutes to find the exact bottleneck. Step number 1, turn on your Hibernate SQL logs and call your slowest API endpoint just once. If you see 50 or 100 select statements flooding your screen for that single click, stop looking. You found an n+1 query bug. Step number 2, if your database queries look clean, open up your Spring Actuator matrix and look for Tomcat threads busy endpoint. If that number is constantly hovering near your maximum limit under normal daily traffic, your threads are exhausted. You are suffering from network blocking. And step number 3, if your threads look completely safe, download Async Profiler and watch your application run for just 30 seconds. If the report shows stop the world, pauses lasting longer than 200 milliseconds, your JVM is suffocating from heap memory pressure. In my experience, almost every single slow Spring Boot application finds its hidden problem at step 1 or step 2. Try running this quick checklist on your own codebase tonight. You might be highly surprised by what you find hiding under the hood. If you want to see the complete step-by-step code implementation on how to fix each of these bugs permanently, check out the deep dive links in the description below. Thanks for watching GK TechVerse. Subscribe and keep upgrading your skills. See you in the next video.